Alright, we're actually going to take everything out, just a little break, we'll be doing that for 20 minutes now, try and shift the gear. So we're going to look at trig functions a little more specifically. You put your laptops side, out of your vision, you won't be able to focus on that. So, for trig functions, they're really, really important, they come up a heap. We've been looking at the unit circle and a few other things. That's scratching the surface on what these things can do. What we're going to look at is the general form. Now, I could replace sine with cos here, and it wouldn't change the general form, okay? All these letters still do the same regardless of whether it's cos or sine. It's just the general shape of the function that's different. So, does anyone know, I'll start by just gauging the room, does anyone know what any of these letters stand for?
The shifts and dilations?
The shift and dilation, it's exactly the same, awesome. So we've done heaps of shifts and heaps of dilations with our previous functions, correct?
Yeah.
Exactly the same here. If you were to guess, what do you think A does?
Dilates.
Dilates it which direction?
Up.
Yep, so vertical. It's got a special name in trig functions. Does anyone know what that is? Very good, amplitude. And we'll talk about that in a second. What do you think B does then, looking at where B is positioned? Dilates it. Yes.
I apologise for the interruption. Any students who have a vehicle parked on the grass bed block in Nelson Street, which is next to the mental health facility, can you please report to reception? So there's any students who
Okay,
have
we'll keep going. What do you think D does?
grass bed block in
Shifts
Nelson
and vertical.
Street.
Yep, vertical shift. Are we seeing that a lot of these things are repeating? Like, once you get your head around like quadratics and logs and exponentials, they all do pretty similar things, it's just slightly different shapes. So that's really, really good that we're seeing that. Now, the horizontal shift, I want to take your attention to this column here before I ask you about the horizontal shift, because I have intentionally written that down. So remember with our horizontal shifts, like if I had a function y equals, I don't know, 2 plus 4, I don't care what it is, right? The horizontal shift occurs when the thing inside the brackets is equal to 0. Are we happy with that? If we think about our exponential functions as an example, if I have y equals 4 e to the 3x plus 2, the horizontal shift occurs when this thing here is equal to 0, correct? So what I'm going to do is simply replace 3 and 4 here with letters. What letters am I replacing them with? B, X, minus C. Yeah, that's B there. Okay. So I'm just going to rearrange this. How do I do that?
Plus C.
Now, what I actually... No. I'll talk about that in a second. Yeah, well, plus C to both sides. C equals BX. X equals... So the horizontal shift is equal to C over B. Cool. Now you will often see this represented as, and I've done this intentionally, minus C over B, because this is often represented as a plus. Why do you think I've represented that as a minus? Now it doesn't matter, you can do it whichever way you want. Why do you think I've represented that as a minus?
That's what it is in other functions.
That's what it is in our other function. We're looking at turning point function for our quadratic. It's x minus h squared. Cool? So if you remember that, go with that. If you just want to go with what everyone else does, this is how it's going to appear in the textbook, then you have your minus in. Sweet? So the orange is optional.
If you have parked
Awesome.
on the grass bare block in Nelson Street, which is next to the mental health